Thermodynamics studies the exchanges of energy in the form of heat and work between a system, which is a given set of objects, and the surroundings, which are the rest of the universe. The simplest system is represented by a fixed number of molecules of an ideal gas, let's say 100, inside a cylinder, of which we can measure the so-called thermodynamic variables that are volume, pressure, and temperature. If these variables are constant over time and uniform at all points inside the cylinder, we say that the system is in an equilibrium state. Notice that when I added the molecules, that was not an equilibrium state, but after a while the situation stabilizes and the system reaches an equilibrium state. Equilibrium will be broken by any change in the values of the variables, but then they will eventually become constant and uniform again, leading the system to a new equilibrium state. The first law of thermodynamics studies how the internal energy of a system changes when the system interacts with the surroundings. What is the internal energy of an ideal gas, and what does it depend on? It is the sum of the kinetic energy of its molecules that is directly proportional to the absolute temperature. So, how can we change the temperature of our system? Of course, we can act on heat control and add or remove heat. Added heat will make temperature and thus energy increase, while removed heat will make energy decrease. That's why we say that added heat is positive and removed heat is negative. But there is another way of changing the temperature without changing the number of molecules. Can you say what it is? We can vary the volume of the gas, applying a force on the piston and producing its displacement, that is, performing a work. When the work is performed by the gas from the inside of the cylinder, the gas expands and the temperature decreases. Thus, the energy decreases. When the work is performed by the surroundings, the volume is reduced and the energy increases. But for historical reasons, we say that work is positive when it is performed by the gas and negative when it is performed by the surroundings. The first law of thermodynamics states that the change in internal energy of a system is equal to the algebraic sum of exchanged heat and work. With a convention for the sign of work, the formula is delta U equals Q minus W.